In this video, we are going to answer this question: how do you find the electron configuration? Or we are going to learn how to calculate electron configuration. Actually, there are three ways to express electron configuration. The first way is orbital diagrams, our second way is spdf notation, and the third way is noble gas notation. This spdf notation is called long form or complete electronic configuration or unabbreviated form of electron configuration. Noble gas notation is called short form, right, or abbreviated electron configuration. In orbital diagrams, we use like lines and we use lines to mean orbital, and we use arrow to mean electrons, right, in orbital diagrams. And in spdf notation we use like this: n x to the power a. This a indicates the principal quantum number, this x indicates the subshell, and this indicate the number of electrons. However, let me discuss all the things. I think if you watch this video up to last, you will be confident, right? So let me define the electron configuration. What is electron configuration? We know that this is the nucleus of an atom and this is the orbit or energy level of atom. So in nucleus we get neutron plus proton, but in energy level we get electron, right? This is our first energy level, this is our second energy level, and this is our third energy level, this is our fourth energy level. So electron will stay in this energy level, right? First energy level has one subshell, right, that is 1s, and second energy shell, we can define the first energy shell by the principal quantum number n. The number n can be 1, 2, 3, 4, right? In first energy level we get one subshell which is s, so we can express 1s. Then in second energy level we get two subshell, 2s, 2p, and in third energy level we get 3s, 3p, 3d subshell, right? These spdf are called subshell. And in fourth energy level we get 4s, 4p, 4d, 4f subshell. This s subshell in presence of magnetic field is divided, right? From s we get one orbital, and from p, from s, right, and from p we get 3 orbital, and from d we get 5 orbital, and from f we get 7 orbital. So we can express orbital using a box or dash. Let's say we are getting s, p, df subshell. S subshell has one orbital, so we'll use one box, and p subshell has 3 orbital, so we'll use 3 box, and d subshell has 5 orbitals, 1, 2, 2, 3, 4, 5 orbitals. So we'll use 5 box, and F subshell has 7 orbitals. So we'll use 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 orbital. So remember every orbital can hold maximum 2 electrons, right? Every orbital. So P subshell can hold maximum 6, D subshell will hold maximum 2, 4, 6, 8, 10, P can hold maximum 6, D can hold maximum 10 because it has 5 orbital, and F can hold maximum 14, and S orbital can hold maximum 2. Okay, there is a simple rule you can use to fill orbital. Look, these 7 orbital are degenerate orbital because this because all energy of all the orbitals are equal. So D has 5 degenerate orbitals. So in case of filling orbital, you have to be aware. So if you have D can hold maximum 10. So if you have 6 electron, then at first you have to place 1 electron for each orbital. Then if you have more, then you can pair, right? You can do pair. So this is the basic look. We can identify the energy level by the principal quantum number n, and we can identify this subshell like S. We can identify S subshell by the azimuthal quantum number L. So the value of L, 0 indicates S subshell, 1 indicate P subshell, 2 indicate D subshell, and 3 indicate F subshell, right? And look, F subshell has 7 orbital. This orbital can be expressed by the magnetic quantum number. We can identify magnetic quantum number by ML. The value of magnetic quantum number goes -L to +L, including 0. That is like this. This is our 0. So -L, +L. So look, for F subshell, we will find the magnetic quantum numbers value. So what will be the value? For F, L equal to 3. For L equal to 3, we get F subshell, and in F we know that 7 orbital. So the value of magnetic quantum number range from -L to +L. That is, for 3 we will have like this value. Look, 0 from 0 to +L -L, that is +3 -3, that is here -1 -2 -3. Here we will have +-L, that is +-3. So -3 -2 -1, then we will have +1 +2 +3. So for L equal to 3, we will have value for ML +L to -L, that is +3 to -3. So we are getting here -3, -2, -1, then 0, then +1, +2, +3. 1, 2, 3, 4, 5, 6, 7. That is, for L equal to 3, we are getting the value of magnetic quantum number, that is, we are getting 7 values. And the 7 values are this, right? So we'll identify, you can identify this orbital by the value of ml, that is 0. This can be -1, -2, -3. This is +1, this is +2, and this is +3, right? So this is the magnetic quantum number, and the magnetic quantum number indicates the arrangement of orbital in space, right? So now we have another quantum number that is called ms, that is spin quantum number. It has only two value, +half or -half. You know that when you will place two electron here, this electron this electron will have +half spin quantum number for this electron will be +half, but the second electron must have -half spin quantum number. That is, in a orbital, two electron doesn't have the same quantum number for all the in a orbital, two electrons doesn't have the same 4 quantum numbers. That is, at least one quantum numbers will have different values for two electrons, right? So to express the position of a electron the position of electron in a atom, we need 4 quantum numbers. I think you have taken the basic, right? Now let us show you how to write electron configuration. Okay, let us take an example. I am taking the example of sodium. Okay, I am taking example of chlorine ion, right? Then I will do the electron configuration of chloride. So let us write the electron configuration of chlorine. You know that the atomic number of chlorine is 17. This means that it has 17 proton and 17 electrons. Actually, we will focus on electrons, so we have 17 electrons. So how can you distribute this 17 electron to different sublevel? Okay, you know that first sublevel has one subshell, that is 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4s, 4p, okay, 4s, 4p, 4d, 4f, right? So look, S can hold maximum 2, P can 6, D can 10, F can 14. So for writing electron configuration of chlorine, we have to draw a line like this. That is, we have to draw a line like 45-degree angle, right? Like 45-degree angle. So first electron will go to 1s subshell. Then we have to go here, and then we are getting 2s, 2s2. Then we will go to 2p, right? 2p, 6, then 3s2. So we have used 6, 8, 10, 12. After 3s, we have to place electron to 3p, 5. So look, we have used 17 electrons. So this is the electron configuration of chlorine. This is a complete electron configuration or long form electron configuration of chlorine, or this is unabbreviated electron configuration of chlorine. So, or this is spdf notation electron configuration of chlorine. So, how can you express this electron configuration by the second way, that is orbital diagrams, right? So, you know that orbital diagrams, S subshell has one orbital, S subshell has one orbital, so we'll use one box. This S subshell also has one orbital, so we'll draw one box, and P subshell has three orbitals, so we'll draw three box, and then we'll use one box for 3s, and for 3p we'll use 3 box because p subshell has 3 orbital. Look, in 1s we have 2 electrons, so the spin of this electron will be different, and for 2s you have to draw like this. For 2p we have 6, so first place 1, then pair up, so 6, then 3s 2, then 5p 5, 3p 5. So at first we have to place one electron before pairing up. Then look, this is the orbital diagram for chlorine, right? And this is the another way to write electron configuration. From this orbital diagram of chlorine, we see that chlorine has one unpaired electron, right? And chlorine has 1, 2, 3, 4, 5, 6, 7, 8 pairs, 8 pairs of electron and one unpaired electron. So now we'll write the electron configuration of chlorine using noble gas notation. So how to do that? So you know that we have noble gas like helium, neon, argon, xenon, radon, right? The atomic number of helium is 2, neon is 10, argon is 18. So to express the spdf electron configuration using noble gas notation, you have to go to the 18 group of the periodic table. In 18 group you will get like helium, neon, argon, right? You need to memorize this element. The atomic number of chlorine is 17, so you have to select a noble gas whose atomic number is immediately lower than chlorine. So 17 and immediately lower than chlorine will be neon. Neon has 10 electron. So you can substitute this 10 electron by neon and you have to use bracket. Then you have 3s2, 3p 5. This is the noble gas notation for chlorine, right? So now you know, and now you have learned how to write electron configuration using 3 methods. So from this electron configuration, we can find out the valency shell of chlorine. The valency shell of chlorine can be easily find out by looking at the highest value of principal quantum number. So here the highest value of principal quantum number is 3. So third shell is the valency shell. So can you tell me what are the valency electron of chlorine? In valency shell, the number of electrons is called valency electrons. So in valency shell we are getting 2 plus 5, that is 7 valency electron. So chlorine is an non-metal and it has 7 valency electron. That is why it will take one more electron to satisfy the octet rule, and it will be chloride ion, right? Okay, from orbital diagrams you can easily find out paired and unpaired electrons. Since chlorine has one unpaired electron, so it is paramagnetic. So now let us show you the another and quick way to write the electron configuration of chlorine. So look, we use spdf subshell to distribute electron, right? This is our first subshell, this is second, this is third, and this is fourth. S can handle maximum 2, P can 6, and D can hold 10, F can 14. So how to write the electron configuration of chlorine? So we need to write the orbital sequence, the subshell sequence. First, you need to consider this S and you need to write this S twice. Then you need to consider PS as a unit and you need to write twice. Then you need to consider DPS as a unit and you need to write twice. Then you need to consider this FDPS, that is 4 subshell together, as a FDPS. You can write more than 2 FDPS. There is no limit for this. This will totally depend on the atomic number. So say with me and forget this and say with me SS, PS, DPS, FDPS. Again say with me SS, PS, DPS, FDPS. Now distribute these 17 electrons, 2, 4, 6, 10, 12, 5, 17. So we don't need this subshell. Now look, S start from 1s, then second S must be 2s, then 3s, and P start from 2p, then this will be 3p. There is no D. So this is the electron configuration of chlorine. Okay, chlorine has 17 protons and 17 electrons. 17 proton neutralize 17 electrons. So what will be the electron configuration of this chloride ion? Chloride ion has 17 protons but 18 electrons. For negative charge you have to add 1 with the atomic number. So how to write the electron configuration of chloride ion? That is, if at first you need to write the electron configuration of neutral chlorine, then you need to add one more electron. So one more electron in the highest value of n plus L. Look here, the n plus L, 3 plus 0 equal to 3 and 3 plus P equal to 4. So highest value of n plus L equal to 4, and in n plus 4 we see that we have 5, P can hold maximum 6, we have 5, and for chloride ion we can add 1 electron here. So this is the electron configuration of chlorine. Okay, so let us take another example so that you can have clear knowledge. Okay, so let us write the electron configuration of chromium, right? Chromium 24. So say with me SS, PS, then DPS, then FDPS. So let us distribute these 24 electrons, 2, 4, 6, 10, 12, 6, 18, 20, 24. So already we have used the 24 electrons a neutral chromium have. Now S start from 1s, then 2s, then 3s, then 4s, right? And p start from 2p, 3p, and d start from 3d. Okay. Look, the highest value of n equal to 4. So this is the outermost shell, and the highest value of n plus l will be, look, for 3 plus 3p. For 3p we have 3 plus 1 4, and 3 plus d, that is 2 5, right? Okay, you know that d can hold maximum 10, but half of 10 equal to 5, and f can hold maximum 14, and half of 14 equal to 7. This electron configuration is stable, right? Is very stable. D has 4, so it will easily try to achieve its stability. That is why it will take one electron from the outermost shell, that is highest value of n, 4s. So it will take one more, so to gain stability. So this is the right electron configuration of chromium. So how to write now the electron configuration of chromium 3 plus? How to? 2 plus, let's say 2 plus. Its atomic number is 24, means 24 proton. It is fixed, and for 2 plus means it will release 2 electrons, that is 24 minus 2, that is 22 electrons. So look, 22 electrons neutralize 22 protons, but we have 2 more protons. That is why we are writing 2 plus. So to write the electron configuration of an ion, at first you need to write the electron configuration of neutral ion. So you need to remove 2 electrons from this. So to remove electron, at first you need to remove electron from the highest value of n, and then you need to consider n plus l value. So you need to remove 2 electrons. So highest value of n equal to 4. So but here we have 1 electron, right? So this electron will be vanished, and you need to remove more 1. But look, here the highest value of n is 3. So now you need to consider n plus l value for highest n plus l value. So 3 plus 2 5, and 3 plus 1 equal to 4. So the second electron will go from here. So it will be 4, right? It will be 4. Now we can say this is the electron configuration of chromium ion, right? Chromium ion. How to express this electron configuration using orbital diagram? So let us do that. 1s, here 2, then 2s, 2, 2p6, p has 3 orbital, 6, then 3s2. This is the orbital diagram. Now 3p6, 1 2 3p6, 2 3 4 6, then 3d, 1 2 3 4, 1 2 3 4 5, 3d, here 4, 1 2 3 4. So can you tell me how many unpaired electrons does chromium 2 plus have? 1 2 3 4, 4 unpaired electron chromium has, right? That is why it is paramagnetic. Okay, you can express the chromium 2 plus electron configuration using noble gas notation. You have helium, neon, argon. Helium atomic number is 2, 10, 18, right? Then you have krypton, right? Krypton is 36. So look, now you have to select a noble gas whose atomic number is immediately lower than chromium's atomic number. So this will be argon. Argon has 18 electrons. So 2, 4, 6, 10, 12, 18. So you can substitute this by like this. Argon, then we have 3d4. So this is the noble gas notation electron configuration for chromium 2 plus. So I am going to give you now another tips so that you can have clear knowledge, right? So when you are going to write electron configuration, look, we usually use spdf. Look, here we have 4 room. These are the principal quantum number, that is energy level. In first energy level we get 1s, in second we get 2s 2p. So when you are going to draw a line like this, you need to draw this line at 45-degree angle, right? So this line and this line is perpendicular to each other. So this is 90 degrees. So if you bisect this angle like this, so this angle will be 45, this angle will be 45, right? So this is a trick actually. Sometimes when you are going to write the electron configuration in this way, sometimes we get confused in case of drawing this line. I hope from this video you have learned a lot of things. Thank you for watching this video. Be well.